All right, for adding polynomials together, so we have this third degree, so cubic polynomial here, being added to this cubic polynomial. What you want to do is collect like terms together. And like terms in this case will be the same variable, but we're not used to seeing this with the exponents, but they also have to have the same exponent. So you want like the y cubes to be together, the y squared, and then you want to combine like terms to simplify. So in this example, and also if we're adding, it doesn't really change anything. Like we don't even need the parentheses here really. So we're doing y cubed plus negative y cubed, which we know it'll cancel out, but we'll write them together. So that's y cubed minus y cubed. And we also always go in order from highest exponent to lowest. Additionally, if there are multiple variables, you want to go in alphabetical order. So A's and B's and C's. Typically, we're just going to have one variable though. So next we have minus 2y squared, and then plus negative 4y squared. So that's minus 4y squared. Then we have 8y plus 2y. And then negative 2 plus 3. Alright, so then you just combine like terms. Y cubed minus y cubed cancels out, so I'm not even going to write anything. Negative 2 minus 4 is negative 6y squared. 8y plus 2y will be positive 10y. And then negative 2 plus 3 will be positive 1. So our final answer, negative 6y squared plus 10y plus 1. Now, for subtraction, we have the minus sign. What I like to do is, to make sure that I don't mess up any negatives, is distribute the minus across the parentheses first. So that's the step one I like to do. You don't have to do it, but I think it'll lead to fewer errors. So distribute, you could say negative 1 or negative, which is the minus. Step 2, collect and combine like terms. So, kind of don't have a lot of room below it. So off to the right, I'm going to write the second set of parentheses. Or actually, we could do it right. A lot of students like to do this. We could change this to a plus and just change all the signs inside the parentheses. So for subtracting and positive, that's like subtraction. Same here. That'll change to subtraction. And this is positive as well, so that's subtraction. So that doesn't change too much. So we have 5x squared minus 15x squared, which gives us negative 10x squared. Negative x minus 20x. So that's like negative 1 minus 20, so negative 21x. And then negative 12 minus 12, which is minus 24. And final answer. So pretty much the same idea, just change the signs first. Alright, now in both of those examples, we had x squared, x constant. We had the same exponents in both of those examples. However, sometimes you don't. So in this example, for missing terms, we have x to the 4th power here, x to the 2nd power, and then a constant. But in the other parentheses, this trinomial has x to the 3rd power, so no x to the 4th. We don't have x squared, and we do have a constant. Now, what you want to do is write terms with the largest exponent first. So let's find the largest. Okay, negative x to the 4th power. Then we see if there are any like terms to combine in the second parentheses, which we said before there aren't. So we're just going to bring this down. Negative x to the 4th. Then we look for the next exponent, which would be x to the 3rd. Now there's nothing in this parentheses with a 3rd power, but we do have plus 3x cubed, so we're going to bring that down here. And then we just have the x squared here, not in the other. So plus x squared. And now just the variable with no exponent, which is technically a 1 as an exponent. So we have plus negative 7x, so we'll do minus 7x. And now finally we actually have a like term we can combine. So we have negative 12 and plus 9, which sign goes with the larger number. So when we combine like terms, it's negative 3. And all of our like terms are combined. Well, we didn't have too many, so that's our final answer.